To better understand motion completely, we need to look and understand position. Now, let's take an example of position. We have a number line here. We draw a number line, just like this. We have 0, -5, and 5. Let me change the color. So we have a ball over here. And what can we say about this ball if its position is right here? Well, firstly, we can say that it's at value 0 or position 0. We can also say that it's at the origin, since the origin is the place where all values are, or all variables are equal to 0. So now the question is, what would happen if the ball were to move 5 units to the left? What can we say about its position now? Well, we can say that it's 5 units away from the origin, or 5 units left of the origin. But we need to make sure that we mention the direction. That because position refers to both the position, so the distance between 2 points, plus the direction. So we can't say it's 5 units away. We have to say 5 units left, or 5 units right, or up and down. We need to mention the direction. Now our next point is that if for instance we change the reference point, so here the reference point was 0 at the first point was reference point was 0. Now if the reference point was -5 and it were to move left again 5 units and it's now at -10, what can we say about the position when it's over here? Well, firstly, we can say that the position is still 5 units left of the origin, because the origin now, or we can say that's 5 units left of the reference point, or the origin. It doesn't matter what you say. As long as the reference point is mentioned, then the distance is related to 2 points. So it's still 5 units left of the reference point. And if we say the reference point is this, and we're asking the full distance, then we say it's 10 units. So if we're asking the full distance, the position from here to here, then it's -10, because this is the reference point. Now, to sum up position, we can call it distance and direction of an object from the origin. So the distance and direction of an object from the reference point. We need to mention the reference point. Now, another point here is the arrows. We need to understand what these arrows represent. So when you have a number line like this, let me draw another number line, and you have, values. If we were to draw arrows, if we were to draw arrows as such, and the balls like here, for example, the arrows here represent the position of the ball and how it moves. So you can see that it shows the direction, since it's like there's a head, and it also shows the distance. Let's look at this quick example. What is the position of point A? Right now we can say that it's at -8. Now, if B is the reference point, so if B is the reference point, how long is the distance, or what is the position of A if B is the reference point? So if B is the reference point, then it went from B to A. So we can say that its position is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units. So 10 units. And we have to specify direction, remember, because position refers to the distance plus direction. So we need to specify both. We can't specify one. So if it's moving to the negative side, so over here, then it's going to be negative. And if it were to move to the positive side, then it's going to be positive. So since it's moving to the left, we can say it's -10 units or 10 units to the left. Now, another important idea is that whenever we look at distance, we're going to be looking at it in a coordinate plane usually. So let's quickly go over this. So at point 0 here, at value 0, we call this the origin because it is the value at which all variables have value of 0. So the origin is when everything is 0. Now, if we were to look at point A here and say that the reference point is 0, then we can like draw a line here and we would find this distance. And then we could say, if this is north and this is east, that the direction is northeast of x units. Now, we'll solve plenty of exercises on finding the distance and displacement later on. But for now, just you need to know that this position refers to both the direction and the position, and direction and the distance. Now, when it refers to direction and distance, this is what you call a vector quantity. There's many vector quantities. We'll go over them in a bit, but we need to know that the vector quantity has direction and distance, or magnitude and direction. Now, a scalar quantity is a quantity that has only the magnitude or only the distance. So just like speed or distance itself is a scalar quantity. So the two quantities we have are scalar quantities and vector quantities. Now, as we mentioned before, scalar quantity only uses the magnitude. So only the magnitude. And vector quantities have both the magnitude and the direction. Now, it's important to note that the direction is referred to with an arrow, with the arrow being where it is and the length of the arrow potentially being the magnitude. Now, a few examples that are important and relevant for scalar quantities and vector quantities are distance, so the distance and displacement, speed and velocity, mass and weight we don't need, acceleration we do, energy, density, power. We're not going to cover anything else. So all we need is displacement, distance, velocity, and speed, and acceleration. There's also position, which is a vector quantity as well that we should know of. And basically, we should understand that distance is a scalar quantity, no direction required, speed is a scalar quantity, vector quantities like displacement, velocity, acceleration, position need to have the direction specified. The next idea we will cover is distance. So distance and displacement. Or you can say distance versus displacement. We need to know the difference between these two. So we know one difference already, which is that distance and displacement is distance is a scalar quantity and so it is a vector quantity. But let's go into more depth and actually understand the difference between them. Let's take this example right here. So we have this number line, or this coordinate plane, and we have a path here. Let's call this path A. So let's call this path AB. Now, we should understand here that if we were to take the distance, so the entire distance of this path, then we have to go through the entire length of the path. So we add all these lines up. However, if we were to take only the displacement, then we would simply go from point A, point B, without going through the whole path, just straight line between both points. Now, first thing you'd be able to notice is that in this case, the displacement is much smaller than the distance. As you can see, it doesn't go through all these curves and paths. The displacement as well ignores any turns. It's simply the difference between the two directions or the 2 points. Now, the final point I need to mention here is that the displacement here, we should mention which direction it's going. So if this is north and this is east, then it's going around east of north, or you can say that. So we have to specify the direction. So before we solve a quick question on displacement, let's look at the actual definition of displacement. The book says displacement is the change in position from initial position to the final position. So displacement is referred to as delta x, which is equal to x1 or x final minus x initial. So this is displacement. We could use this formula, or we can simply add it or subtract it as vector quantities. So I just wanted to quickly mention the displacement formula. Now for the question we want to solve over here, we have this coordinate plane where we have A, B, C, D, E, F points. And the first question we're going to solve, or we're going to try to solve is, what is, so question part 1A, find the distance. So to find the distance, we're going to add all the points, all the lines, basically the entire length. So from A to B, it's equal to 4, so 2, 4, 6, 8. So 8 units or 8 meters here. So from B to C equal to 2, 4, 6, 8 as well. From C to D, it's 4 meters. 4 meters. And from D to E, we have to find the Pythagorean theorem because this isn't actually 2. This is a little more than 2. So we need to find it. And the best way we can do that is Pythagorean theorem. So this is side 4. This is side 4. So this is 4 radical 2. Or you can do the rule for the Pythagorean theorem, which is uh, hypotenuse. So c squared is equal to a squared plus b squared. And then you substitute. So c squared is equal to 4 squared plus 4 squared. C squared is equal to 16 plus 16. C squared is equal to 32. Then radical, radical. Then you get C is equal to, and then you can just put this in your calculator. So radical 32 is around 5.6 meters. Now we can put 5.6 meters here, and then from E to F around 4 meters. So now since it's distance, we want to add everything up. So 8 plus 8, 16, plus 4, 20, plus 5.6, 25.6, and then 29.6 meters. This is the distance. Now for displacement, so question 2 is asking for displacement. So find the displacement from point A, point F. We're going to simply find the distance between, or displacement between AF. So initial minus final. We can use a formula if you want. So displacement is equal to x final minus x initial. So x final is 10 minus a, which is 2, and we get 8 meters. Now, it's important to note that here it's north, here it's south. So if it's moving from, since it's moving upwards, it's going to be positive 8. If it were, if I've asked you, for example, find the displacement from F to A, then it would be negative 8 since it moved downwards. That's the difference between displacement and distance. It asks for the difference, and that's for the difference between the 2 points, as well, the change in the 2 points, as well as the direction. So you need to specify it. So here it's 8 meters displacement and 29.6 meters distance. Now, as we can see here, we have a number line with 4 different points. Point t equals 0, where it's at negative 3. Point t equal 1, where t1, which is at equal to 3. t2, which is equal to 9. And t3, which is equal to negative 9. Now, if we were to solve question A, which asks for the distance covered from t0 all the way till t3. Now, if we were to solve it like this is wrong. This is the displacement. We need the entire distance, so it should follow the entire length of the path. So here it gives us the seconds it took. So at t0 to t0, it's at rest right now. It didn't move yet. At t1, it's at 1 second, and it moved from t0 to t1 in 1 second. Then in 2 seconds, it moved from t1 to t2 and reached the 9, and then took 3 seconds to reach all the way back till t3. So we should follow this path, and yeah. So from t0 to t1, just count distance. So 1, 2, 3, 4, 5, 6. So 6 plus 1, 2, 3, 4, 5, 6 plus, and then we go all the way back. So 1, 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then 13, 14, 15, 16, 17, 18. So plus 18, which is equal to 30. Now, the SI unit of distance is meters, so we can say meters, but it didn't really specify the unit here, so we can just have 30 units. Now, the next part of this question is asking for the displacement vector of t0 to t3. So as we stated before, if it was a distance, we go through the whole path, but if it's a displacement, we simply go from t0 to t3, ignoring the entire path. And of course, since it's displacement, we should mention the direction. So simply, we count how many units it's away. So it's 6 here. So 6. Now, what's the direction? We look at the direction it's going, and it's going to the left. So we would say -6 units, or whatever you want to call it. It's -6 meters, -6 units. That's the displacement vector from t0 to t3. Now, the final question is asking for the displacement vector from t1 all the way till t3. So from t1, so here t1 all the way till t3. Now, of course, as stated earlier, from t1 to t3, it's the displacement, so we just draw a line straight from it. We don't follow any path, and we just count 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, and we get the addition. Now, what's important is when we add displacement vectors. So it's -6 plus -6, because we add from t1 to t0, which is -6, or t1, t0 to t3, it's -6, or you can just count them all together as -12. It doesn't matter. However you do it, as long as you get the final answer, and the units, it should be in units. Now, for this question, it may get a little tricky and could get quite hard to find the displacement here. So let's quickly go over it. First, let's find the distance, and then we'll find the displacement. So the distance here, we simply go from point A to B to C. So it would be 15 kilometers. Now, if I were to ask you what's the distance or the displacement from A to C, so from point A to C, we would have to find the, so this is the distance between A to B to C, or from A to C. Now the displacement from A C is equal to is equal to this hypotenuse of this triangle. So as usual, we do c squared is equal to a squared plus b squared. C squared is equal to 5 squared plus 10 squared. C squared is equal to 25 plus 100. C squared is equal to 125. Radical. C is equal to radical 125, which is on your calculator 11.18. So 11.18. And then kilometers. Now, if we want to specify the direction from A to C, it would be hard because we should find the angle. If we want to find the exact angle, find angle theta here, or find the angle here, angle theta here. So we need to calculate it. Now, the best way to find this is by taking it on the x-axis. It's harder to do it on the y-axis, so we should always calculate the angle from the x-axis. This means that our angle should be along the x-axis and not along the y-axis. So here. So here would be along the y-axis, and here would be along the x-axis. So it should be along the x-axis. So let's calculate this angle right here for the direction. Now to find this angle, simply we're going to do tangent is equal to 10 kilometers over 5 kilometers. Now on your calculator, you'd put tan -1, but it's best to take the tangent in this case because 5 kilometers and 10 kilometers is given, unlike your hypotenuse is 18 kilometers, 18.8 kilometers. This is what you calculated. If it was wrong, then you're going to get both questions wrong. However, if you just take the given, then and you got this value wrong, then you would only get one question wrong. So taking tangent is just overall safer. It's a safer path. So you could use sine and cosine. It's fine, but taking tangent is a safer path. So just calculate the tangent of 10 kilometers over 5 kilometers. So let me quickly, and you get 63.343 degrees. So that's the angle between. So what your final answer will look like if you were to say 8c, so it'd be 11.8 kilometers with 63.43 degrees. So the final point for this lesson is resultant. So what is the resultant? Well, the resultant is the sum of two or more vectors. So it has to be 2 plus vectors. Now we know that vectors are represented by arrows. So the arrows represent the magnitude. So magnitude, and here's the direction, wherever it's pointing. So to better understand vectors, let's take a quick example. If I were to have, for example, a man who moved 5 kilometers to the east, and here's north, here's east for reference. He moved 5 kilometers east. Then we can say that he moved 5 kilometers east. So this would be our vector. Now, if we said that he then moved 5 kilometers or 7 kilometers back, so west, 7 kilometers west again, then we could say he also moved 7 kilometers west, and it would be the opposite direction, meaning that if we were to find the displacement between the first one, where it's point A, second one where it's point B, then we could say here that it's plus 5, since east is positive, and then minus, then we add it first, so plus, then minus 7 kilometers. Since we always add the vectors, we don't subtract vectors, we always add vectors. So plus east and then minus. So plus 5 kilometers, then minus 7 kilometers. So the displacement here is 2 meters or 2 kilometers from point A to B. All right, for the final thing we're going to do is we're going to solve a quick exercise on resultants and vector quantities, or vectors in general. So we have 3 vectors here. Vector A, which is 5 kilometers west. So we just mentioned the direction. So and here's north, and here's east. So 5 kilometers west, so that means the arrows, or the vector is like that. 5 kilometers. No, 5 kilometers. And then 12 kilometers east, so it's moving that way, and it's 12 kilometers. And then 8 kilometers west, so again, it's moving back, 8 kilometers. So now we have question 8 asking vector A and 2 vector B. So if we were to substitute the values, so you have 5 kilometers west here, so A is 5 kilometers, west is negative, so we should substitute it with a negative sign, plus 2B, B is positive, so 12, 2, 12, so This is our vector. So we have -5, which is a. We can find a by taking it from the given. And then 2 times 12, since we have 2b here in the formula. And then we just substitute b. And it's positive because we said east, not west. And then we just add it up. So -5 plus 24, which is equal to 19 kilometers. Now, find the direction at the end. We should always mention the direction when we're talking about resultant. So to find the final direction, we look at the sign. It's positive, then it's going east or north. So here in this case, it's going 5 kilometers east. So that's our first question. Now for the second question, we have -2b and 3a. So we already know that 2b is negative. We already know that 2b is going west. So we are going to substitute it just as it is. So -2 into -5 plus and 3a. So oh wait, b is 12, not 5. So -2 times 12. And then we add it to 3a, so 3 into -5, as a is -5, -5, and it's negative again because west is negative value. So we just add it up, so -24 plus -15, and then we find out that the values are, since negative plus negative, so in the end it's going to be negative. And we find out that the values here, if we add them up, it's 39, so -39. We can specify negative here, or we can just say 39 kilom. We can say 39 kilometers. Uh, it's going in the negative direction, so west. Just west. Make some space actually. West. So west. We shouldn't say -39 kilometers west. We should just specify one direction. West specifies the direction being negative. We can say -39 if you want. They're both the same thing. Just don't mention them both. Same case over here. And finally, we have a vector a. So a is 5 kilometers west, so -5, plus b, which is 12 east, so it's positive. So 12 plus -2a. So plus negative a, which is -5, and then we add them up. So -5 plus 12 is 7, plus negative times negative is positive, so 10. And then we get the answer 17 kilometers east. And that is how we find and calculate resultants. That will be it for the physics lesson 2.2, where and when. If you have any questions or want to ask anything at all, you can ask it in the Discord server or down below in the comments. If you want to find any other tutorials or other physics tutorials, you can find them on the channel, and that'll be it. Enjoy them.